today we talked about the end of Chapter 5 for energy and work, which is the rate at which energy is transferred. So we can define the power to be the work done on an object divided by the time in which that object was experiencing that work. So that would therefore be the power delivered to an object. Or it's the power delivered by an object if you're talking about the work done by something over a given period of time. So that is the work over the given period of time. Or, since we know that work also has the definition involving force, then it would be the F delta x, which is another way for talking about work, divided by the change in time to give us F times the average velocity. So the average power is equal to the work over the delta t, and it's also equal to the force times the average velocity. So again, just thinking about what's happening with an object, the power delivered to an object is equal to the work done on that object in a given time period, or also equal to the force done on an object while the object is moving at a constant velocity, or you can talk about the average velocity an object has after it's experienced that force. Okay, it's some force that's acting on it, and we talked about a golf ball, for example, being hit by a golf club. There's some force that's being applied to the golf ball in a given period of time that results in it having a certain velocity. And so that would be the average velocity of the situation, and the force that's been imparted, well, that's acted on the golf ball would be the power that's been delivered to the golf ball. So the units of this are joule per second, okay, which is a watt. So a 100-watt light bulb delivers 100 joules of energy per second. A 1,000-watt light, something that's delivering 1,000 watts of power is giving you 1,000 joules of energy per second. And I mentioned about how the unit of horsepower that is commonly used is actually equal to, if we talk about converting it to SI, is equal to about 746 watts. So 1 unit of horsepower is equal to the power given you by 74.6, actually 7.46 100-watt light bulbs. Okay. So the other thing that I mentioned with regard to this is that electric bills, electric power generation is often measured in terms of kilowatt hours, which is the amount of power that you have times the amount of time that you're using it. So because if you have the amount of power times the time, that gives you the total energy. So 1 kilowatt hour will be equal to 1,000 watts of energy used in 1 hour, or if we want to actually convert that, since this is joules per second, let's make that into seconds too. 1,000 joules per second times 3,600 seconds would give you 3.6 times 10 to the 6th joules of energy. And if you talk about running a lamp that has a 100-watt light bulb in it for an hour, then that means that you are using 3.6 times 10 to the 5 joules of energy during that time span. So electric companies will be able to tell about the power output, the amount of power that you're drawing based on whatever it is that you're using, the amount of time that you're using it for, multiply those things together, and you can figure out exactly how much energy you're using, which, as you could imagine, is very important in this day and age with our energy-driven culture. So that was the end of Chapter 5 with regard to work and energy, looking at now the rate at which energy is transferred. Because we talked about the conservation of energy, we talked about work, which can give energy to an object or take energy away from an object, and now we talked about how fast an object can actually be giving energy or be taking in energy, and that being measured by the actual power which is the work done on that object or done by the object divided by the time in which that process is happening.